In case you missed it, I'm building an app to keep track of budgets, all using Phoenix LiveView. Make sure to start with video 0. Okay, let's pick up where we left off. A generated LiveView app with auth, customized to allow users to have names. As I mentioned before, Phoenix projects use schema modules to represent database tables. This concept comes from the ecto library, which serves a similar purpose to object relational mapping or ORM packages in other languages. In the Budgie app, the central schema is the budget. Owned by its creator, a user, this will have a name, a description, and a time range. Rather than use code generation for the schema, let's make it by hand. That way it won't just be magic. Phoenix data models get broken into contexts, which have a history and domain-driven design. This separation can help projects scale, but I use them pretty sparingly in smaller projects. For the rest of the Budgie app, we'll do most of the work in a context that I'll call tracking. So let's create a new directory under the Budgie project called tracking. And in there, let's create a budget schema. That'll be budget.ex. This contains a UUID primary key and all of the fields from the diagram. Just like the user schema, we also have a change set. It's important to set restrictions on the lengths of properties containing user input so they don't abuse your app and fill up your database with nonsense. For this reason, I set the budget name to a max of 100 characters and the description at 500. The good thing is, this can always be changed in the future if a legitimate user ends up needing more space. Now, just like our user's name in the last video, we'll also need to create a database migration file to make sure the budgets table exists. For that, we'll use mix ectogen migration, and we'll call the migration create budgets. I use this function, even though I said no code generation, because it puts the timestamps at the beginning of the migration file and puts it all in the right spot. It ultimately doesn't really generate anything more than that, and I think that's probably okay. So I'll fill this out and we'll talk about it. In this change, we're going to create a table called budgets that doesn't have an automatic integer primary key. Instead, we're going to add an ID field that is the primary key, but it has the type binary ID. Binary ID in ecto is equivalent to UUID. Then we've got the other fields. We've got a reference to a user. So the creator ID is going to be a user's ID. And we also create a database index on the budgets table on the creator ID field. This will allow us to quickly look up budgets belonging to a specific user. I also added a check constraint. This is a database level restriction that makes sure a budget never ends before it starts. It's perfectly valid to have restrictions only live in your change sets, but database level constraints can't be violated even if you go in with direct SQL access. We'll come back to this later when writing tests, since ecto change sets have a great way of supporting and reporting these guardrails. So I'll run mix ecto.migrate. And now the table has been created along with the index and the constraint. We can also go into the database and just double check that that was created by listing the tables and seeing that budgets exists. We could access and query the budget schema from anywhere in our app, but it's a best practice to create a module as the interface for each context. So back in the Budgie directory, we'll add a file called tracking.ex. By convention, these have the same name as the directory that contains the schemas. In this module, we will alias the database repository and any schemas that we might reference. We'll also import some macros that'll help us build up queries. With that structure in place, let's add a method to create a budget. So the create budget function takes a map of attributes defaulting to an empty map. Within its implementation, we pass an empty budget instance into the changeset function, allowing it to handle validation and mapping. If the changeset looks good, the insert method will return an OK and the created budget. If there's any errors, the changeset will be returned in an error tuple. Let's give it a try in our IEX terminal. I'll run IEX-s mix Phoenix server. So I've got an IEX session running, and I can run budgie.tracking.createBudget with no parameters. And the result is an error saying that certain fields can't be blank because they're required, and that it is not valid. So we're going to need a name, a start date, and an end date, as well as a creator ID. Let's go grab the user ID for one of the users I created last episode. We'll do that by going to the accounts context and running the getUserByEmail function. That gives me ca@example.com, which has an ID starting with 1BAA. Now I can call create budget with the required values. So we will create a budget with a name of Hello Budgie, a start date of 2025 January 1st, end date at the end of January, and that user's ID as the creator ID. Since the validation passes, the budget was inserted into the database as expected. Instead of getting an error and a change set, we got back OK and a budget instance with all the properties we specified. Let's add some tests, and then we can start wiring this up into the app's UI. So over in tests/budgie, it's time to add tracking test.exs. This is a database test, so we'll use data case. Defined in the test support directory, this sets us up with a sandbox of our SQL database that rolls back automatically between tests. It also imports some things that'll be helpful inside of tests that are specifically for data access. So we want to describe the budgets. Let's see what a test for that would look like. This first test makes sure that the happy path is covered. We use the user fixture to create a user instance, create a map with all the required properties, and make sure everything is set and returned properly. If I run mix test, we'll see that this one also passed alongside the other test suite. And one thing that I really love about Elixir is that the tests tend to be pretty fast. We could also test something a little bit more unhappy, like what if there is a name missing in the input? Are we going to actually get that error back? When create budget fails, we can grab the change set and make sure that it's invalid, specifically that the name field is included in that error set. And if I run that test, we should now have 136 tests that all succeed. Now let's get into something a little bit more interesting. Remember that in the migration file, we set a constraint that says that the end date must be greater than the start date from a database level. So if I try to insert a value where we start in December and then end in January of the same year, we would expect to get an error back just like before. But if I run this test, I'll actually make this full screen. If I run this test, an error gets raised. There's a difference between returning an error tuple and raising an error. If you're coming from other languages, raise is more like a panic or an exception. And this helpful error message tells us what we were missing. The change set doesn't know about the database constraint from the migration file, so it just blows up. Luckily, we can use a function called check_constraint in the change set to properly handle validation. If I take a look at the documentation, this says that it'll check for a check constraint in the given field. It relies on the database to see if that was the constraint that was violated. So if we did a create constraint, which we did, then check constraint can be added to a change set to gracefully handle that error and push it back into the errors without raising. So let's do just that. We'll go into budget.ex within the change set, and let's add check constraint. I put it on the end date. This is a judgment call. Making the error message go on the end date input when we build out the UI seemed right, but it could have just as easily gone on the start date. The name property needs to match the name of the constraint in the database. We set this in the migration, and the message is what we'll put in the form if there's a problem. Before we make an assertion on what that change set's going to look like, I'm going to run a debug with that change set. And when we run the tests, it'll log out what that object looks like. So full screen here, mix test. This is now what it looks like. So instead of raising like before, we actually got that error change set tuple, and the change set has the error message on the end date property as we expected. Now, Phoenix projects automatically come with a helper function called errors on. Let's see where that's used. And it's already used in the accounts tests. This is actually just a small little helper that goes through the error messages and makes it easier to pattern match when making assertions in tests. So let's make one of those assertions here. So we want end date to have the message must end after start date in this specific test. So I'll run mix test, and it succeeded. Now we can also strengthen our assertion on the name field from the previous test. Instead of saying we want to make sure there's an error on the name field, we can say we want this error on the name field, which is can't be blank. Once again, there are no test failures. It all succeeded. Now I'll quickly add a couple more functions to the tracking context. These are list budgets and get budget. And if I run one of these in IEX, so I'll go back over to the app and run budgie.tracking.listBudgets, we can see the budget that was created before is returned. Now the getBudget function returns the budget if it's found by ID or nil if it can't be found. For timing, don't worry about testing these. The tests will be in the linked pull request in the description if you want to check them out. Now let's do something really basic to show the budgets in the system. A single view with a data table. Phoenix projects come with a core set of UI components that can be used to scaffold out interfaces without much fuss. They are also used by code generators if we start using those. These include things like modals and flash notices and forms. There's a whole bunch of methods in here. So let's go into the Budgie web/live directory, and we'll call this budget list live.ex. If you're not familiar with the use statement, don't worry. It's a way of running a macro to define behavior and callbacks, as well as importing methods and aliases. This one can be found in our web module. And if we find the LiveView method, we can see that it will pull in Phoenix LiveView. It makes some helpers available, including translation, LiveView.js, and most critically, those UI components. The LiveView lifecycle includes two main callbacks, the mount and the render functions. I'll stub out a pretty minimal implementation here just so that we can get something on the page, and then we'll iterate from there. So when we mount, we're not going to load anything. We're not going to do anything. We're just going to say that was okay. And then in the render function, we return something with this tilde-h, also known as sigil h. It indicates that the result is a HEEX or HTML embedded Elixir template. This requires that the argument has the name assigns and lets us embed expressions and variable bindings. But first, let's make sure that this thing can render at all. So let's register it over in router.ex. Router.ex is where all of your routes are going to be, naturally, and it is broken down into things that happen when the user is not authenticated, things that require a user to be authenticated, and then other general things that should exist within the app. So we're going to add budgets to our authenticated routes. So you can only see this when you're signed in. If you go to this route and you're not signed in, we'll redirect you to the login page. And now, if I open up my browser to localhost 4000/budgets, I'll see that message. All right, let's load the budgets in the mount function. So instead of just returning OK and the socket, what we're going to do is run tracking.listBudgets, that function we called earlier, and then run this assign to make the data available to the render function. That's why this is called assigns down here. And now we can list this out in the view. Instead of just returning some canned text, we can return a list, and it uses this :4 construction. Before LiveView 0.18, this would have looked a lot more messy, but we have these special attributes that begin with a colon in conditional and iteration situations. And the @ sign refers to the assign with the name budgets, and this binding lets us render the name of the budget for each item in the list. If I go over to the page, there's that hello budgie that we created before. A list leaves a lot to be desired. Core components also includes a table, so let's use that instead. Put that in here, and now we've got a table that has the name, the description, start date, end date, and the creator ID. The way that this works is it has slots, in this case columns, that allow us to declare the content of the table and not really have to worry so much about the HTML structure. This isn't magic. If I go into core components and take a look at table, it shows an example here that looks a lot like what we just did. And then it also says that there are certain attributes available, including this slot, which themselves can have attributes. And internally, this is just a little bit of manipulation to get this structure into HTML. But the really cool part is we don't have to worry about this. Over in our live view, we just get to use that component. And you can create your own components. There's nothing special about it. Keep that in mind if you want to start doing more UI customization, which we will be doing later in this series. But I've made a big fuss about names, and showing an ID is not great. So what if I wanted to show the creator's name instead of the ID? If you're thinking budget.creator.name, you're on the right track. But this crashes with an error message. The creator is not loaded. This is a way that Ecto differs from other ORMs. It doesn't lazy load relationships. And this is for a good reason. Lazy loading can cause a ton of performance issues, including the dreaded n+1 error, where a table like this would end up running one database query per row. At scale, this can cause huge headaches for your users and your DevOps team. In Ecto, we can run something called preload to explicitly fetch related data. As its name says, it will preload the associations into result sets from queries. So if we change our mount function to run this through a preload from the repo, and we say we want to preload the creator field, the view is going to do what we wanted. We can see that the creator, not ID, the creator name is CA, the user with ca@example.com from our terminal earlier. So how are we going to go about testing this? Let's go to tracking test, and we have some pretty good examples of how to create a budget. Obviously, we're going to need budgets if we're going to be presenting them in a list, but that's going to get really repetitive and hard to maintain. Thinking back to the accounts test, that module used fixtures. Let's do that for the tracking domain so we don't have to copy all this stuff when we're testing views that just rely on budgets existing and aren't exercising the mechanisms of actually creating the budgets. This one's going to be a little bit more complicated than the user fixtures, but bear with me. So in our fixtures directory, let's create tracking fixtures.ex. This one's a little bit more complicated than the user fixtures since we have to assign a creator when one is not provided to us. There's a more scalable solution we'll use in future videos through a library, but I want to show how this can be done by hand. The map.putNewLazy function is perfect for this. If the creator ID is present, this function doesn't execute. But if there is none, then this inner function gets called, which will create a user for us and then set the value of creator ID to that user's ID. Recall that in Elixir, the last expression of a function is its return value. So when we run this budget fixture, we're going to take the attributes that were given to us and then make sure that we have these valid budget attributes that are merged in. And if no creator ID was set, we will create one for the caller. Finally, we create the budget and return it. We should probably backport these fixtures into the tracking test so that everything comes from one place. So in our tracking test, instead of having this map that we need to maintain continuously every time that we add a new field or change what it means to be valid, instead let's import budgie.trackingFixtures, and then valid attributes can be valid budget attributes, and let's set that creator ID to user.id. We can get rid of the rest of this. And then if we run mix test, our tests still succeed. We can do the same thing for the name requirement. And instead of just using this name attributes without name, we can get a little bit more explicit and say that we are using valid budget attributes, but removing the name. And that should work just as well. Finally, we can do a map merge down here to set the start date and end dates as expected in our time test. And now our tests are just a little bit more clean. Actually, it just warned me that I'm not using that user anymore because that wasn't really relevant. There we go. All of our tests are still passing, but now they're just a little bit more clean and can adapt as we evolve our data model. With that out of the way, let's actually get to the LiveView test. So the LiveView test is going to be in Budgie Web Live. We're going to give it the same name as the original file. So budget list live, we'll add test.exs. That's a lot of new code, so let's break it down. First, we are pulling in con case, very much like data case. This just does some stuff that helps us with our sandbox, creating a connection and making registration and login functions available. Then we import LiveView test. This gives us some helper functions for actually rendering a live view. and we're importing our tracking fixtures that we just created. In this setup function, which runs before every test, we make sure that there's a user available. And then when we describe our test scenarios, we have this context argument that will take in the connection created by concase and the user created by this setup. Now we can create a budget with the creator ID set to that user's ID, just like we did a moment ago. We log the user into the connection, and then we do a LiveView render of the budgets route, that one that we just created. The live function returns an OK tuple, a reference to the LiveView process, and then the rendered HTML if everything succeeds, and an error if something goes wrong. Then we can make some assertions that the HTML contains that budget's name and that budget's description. When I run this test, everything succeeds. We know that that worked. But there's another interesting debugging tool that's available when you're doing LiveView testing. So if we remove this underscore from LV, indicating that we're going to be using it, we can run open browser LV. So when we run the tests, it will actually open up my browser to that rendered HTML of that view. This is super handy when you're trying to debug test failures that are within a UI. And it's one of my favorite things about LiveView. I never thought that I'd get so excited about testing, but well, here we are. Now, it would be pretty awful if every user had to open up an Elixir command line on our server to create a budget. So let's add a form. As we said before, forms run on changesets. So let's expose our budget changeset function in the context module. Over here in the context module, we can add change budget, which is just a proxy to the change set and has this attribute default set. I'm going to model our budget creation form as a live component. This is a component that lives within a LiveView process, handling its own state and able to contain its own callbacks. So we'll create the create budget dialog live component in the live directory. And I'll paste in the initial implementation. Unlike a LiveView, a live component has a little bit more simple of a lifecycle, and its primary method is update, which is like mount, but it has assignment variables from its parent LiveView. In here, we'll create a change set, convert it to a form structure, and assign it, along with all of the assigns from the parent, to the socket. For rendering, we do have another option instead of putting that sigil h render function directly in the implementation. So I'm going to create another file with the same name, but with the suffix html.heeks. And this is where we will put our HTML template. This form contains inputs for each value, along with a submit button and some basic styling. It uses core components, form and input, to interact with the Phoenix form that we're binding to the form assign. Whenever there's existing values or errors, these components will render them properly. There are 3 important Phoenix HTML attributes on this form. Phoenix target says that the component will handle events emitted by the form. That's what myself means here. Without this, the events would go to the parent LiveView. Change says what to do when a form field changes. In this case, we'll run validate. And submit says what we'll call when the form is submitted, either by hitting the enter key while a form field is active or by clicking that create budget button. Over in our router, let's create a new route and we'll call it budgets new. This will be the creation route. And then we're going to add an atom to the end and we'll set it to new. This option is called live action. The value is passed as an assigned value on the socket so that the LiveView knows that the user wants to do something specific. Compare this to other libraries where you may explicitly be doing some matching on the URL. Now back in our list view, inside of this template, what we can do is conditionally show a modal with that create dialog only if the live action is new. Modal is one of those core components I mentioned earlier. We're only going to show this when live action is that atom new, and then we're going to show a live component, our create budget dialog, and we'll pass in the user so that it's made available to our budget dialog. I'll also add a link to the new budget form from the list page. This should open the modal because we'll be navigating to the /budget/new page. If I open this up, I'll see Oh, that button is huge. Okay, let's fix that real quick. So I'm just gonna wrap this in a div, flex, move everything to the end. And okay, that's a little better. So if I hit this button, we will open up the modal. And if we were to start filling out this form, what do you think would happen? If you guessed that the LiveView process would crash, you were right. And there's an error message in our server that suggests that a event called validate was not being handled. That's because we never wrote the callback. So let's add the two event handlers referenced in the form, validate and save. Over in the dialog, we can add those methods. So what validate is going to do is it's going to run our change set with an action of validate and then assign that back to the form. By doing this, we can actually enforce things like can't be blank, max size. That's how all the magic works. Now, saving is a little bit more complicated. What we do is we force the creator ID to be the current user's ID passed in from the LiveView. This ensures that a user, even if they were to put a creator ID form input on the page, wouldn't be able to create a budget belonging to someone else. This will always override that property, and that happens before we pass it to tracking.createBudget. Then we pattern match using a with expression. If the budget was created, we put a message on the page and close the modal. If there was an error while saving, we do what we did in the validate function. Update the form on the assign and pass error messages back to the user. So let's create a budget real quick. And let's see if we can make an invalid budget by setting the end date before the start date. There's our error message showing right up into the UI. And if I put this at the 28th and hit create budget, that new budget is now in the form. Everything works as expected. But how do we keep it working as expected? Obviously, we're going to write some tests. It's common to test live components by running them in the context they'll actually run in. In this case, I'm going to add some tests to the LiveView under a different describe block. So first, let's make sure that the modal is shown when we navigate to the budget's new route. So we'll go into the budget list live test and create this new block, create budget modal. What we're going to do is make sure that the element create budget modal by ID will be present on the page. We'll run the test. It succeeds, and it actually just, I still have that open browser. Let's remove the open browser debugging call, move this back to an unused LV, run the test once more. Okay, so that worked. We know that the budget modal is now on the page when we are at budget/new. That one's simple enough. Next, let's fill out the form and assert that we get an error when the user's name is an empty string. That will be this test. So we make sure we sign in, we hit that route, and then we grab a reference to the form. The element helper will produce a reference to a specific item on the page. Then the render change function will perform a Phoenix change action on the referenced element, triggering any callbacks that might happen and returning the resulting HTML. Finally, we make sure that can't be blank is presented on the page, which came from this name being blank. Let's run the test. Okay, this one trips me up all the time. The HTML on the page gets encoded, which makes string comparisons fail. If we take a look in here and find can't, actually it's can ampersand pound 39 semicolon T. This has to do with the HTML encoding. And there's actually an HTML escape utility function in a package that we already have installed. I generally import this helper in my concase module so that it can be used for string comparisons involving HTML. So on all of our concases, let's import this plug.html.html escape function. Honestly, I don't know why this isn't included by default. So now if I go into the test, what I can do is say, assert that the HTML has the escaped value can't be blank. This is going to convert that apostrophe into that ampersand thing. And now the test will succeed. If you run into this, it's perfectly normal. This is just something that happens when you're comparing HTML instead of comparing the underlying text. All right, and finally, let's make sure that we can actually create a budget. This is very similar to the previous one. We sign in, we grab the form, and then we render submit, where we set the budget to an object containing a name, description, start date, and end date. Then we follow the redirect that does what you'd expect it to do. We make sure that the new page has that little pop-up that says budget created and that the new name of the budget is present in the list view because it was created. Then we use our tracking context list budgets function to make sure that this created budget is the only budget that's been created and that it was saved to the database. And then we interrogate it just to make sure that it has the values that we would expect. Now in this whole video, I've been signed in as a different user, someone else at example.com. But what kind of app shows every user the private data of every other user? Not a very good one, that's for sure. Clearly, we need to limit the results based on who is signed in. In many Phoenix projects, list functions take a keyword list argument that lets the caller specify things like prefetching, sorting, and filtering. Let me show you what I'm talking about. Over in our context module, instead of list budgets just saying give me everything, let's say that by default, we're going to have no filtering, no criteria, but whenever there is a list of criteria, we're actually going to dynamically construct a query. So when the list budgets function is called with an argument of user, we are going to make sure that there's an additional where clause that locks it down to that user's ID. Let's see what that looks like in IEX. So if we grab a user, then we can call list budgets with user of that user and only see the budgets that were created by them. Now, if I don't set user, it's going to give me all of them. That's the behavior that we currently have. So it's not going to break anything. And if I run my tests, everything is still the same interface, so it's all going to still work. We could also extend this to do things like preloading by adding another match to this reduce. So now preload will also perform a preload. That means that we don't have to reach into the repo when we're doing things like adding the creator to our budget. This construction is possible because ecto queries are just data structures that get submitted to a repository. A query alone does nothing without being passed to that repository, which manages the side effect of actually calling the database. You'll see this list criteria pattern in many Phoenix code bases, since it's very flexible. Now we can update the mount function in our list view, and it should do exactly what we need it to do. So over here, instead of listing all of the budgets, we're going to list budgets where the user is the current user, and we're going to preload that creator. Now, if I go into the UI, I only see the budgets that I created. There are more advanced ways to do this, like using packages to consistently apply access control rules. We'll use one of these packages later on when we implement collaborators, letting users share their budgets with others. But that's probably enough for today. We've created our first schema, set up a context module to manage its access, added a list view and a creation modal, all with validation and user scoping. I'll leave some more tests in a PR in the description if you want some more examples. Next time, we'll get even deeper into the app. This has been Code and Stuff. Thanks for watching.